Okay, welcome to AP Physics. This is Chapter 2, One-Dimensional Kinematics. So, kinematics is going to become the basis for your learning in physics. So, understanding this chapter along with Chapter 3 are very important. Okay, so Section 1, Displacement. Displacement, before we can actually understand what kinematics is, we have to break it up into its components. So we go to displacement, which is our first section. So displacement is a vector, so it has both a magnitude and a direction, like every vector. And when we're solving for displacement, we use the equation that the change in x is equal to the x final minus the x initial. X is going to be our distance. Our displacement is basically going to be our direction and our distance from our initial point. So we use that by finding that the final distance minus the initial distance. Now the SI unit for displacement is meters. So when we're doing problems, they're going to give us sometimes in meters, or they're going to give us in kilometers or centimeters. Now we have to change that into meters in order to do the equation properly. Okay, so here in one of our check your understanding problems, we have the problem that a honeybee leaves the hive and travels a total distance of 2 kilometers before returning to the hive. What is the magnitude of the displacement vector of the bee? So in order to do this, we have to use the standard equation of displacement. So that's going to be our change in x equals to our final minus our initial. So we know that his initial distance away from his hive is 2 kilometers, and then his distance back to the hive is again 2 kilometers. So when we plug it into the equation, we get that 2 kilometers minus 2 kilometers equals 0 kilometers. Another way to do this is thinking conceptually. You could say that his total distance traveled from the hive is 0. So therefore his displacement is 0. Okay, so for this problem, they tell us that for each of the 3 pairs of positions listed in the following table, determine the magnitude and direction, positive or negative, of the displacement. So we start off by writing our equation, that our change in x is equal to our final minus our initial. So for number 1, or for A, they give us that our final position is 6 and our initial position is 2. Therefore, 6 minus 2 is 4 meters, which is our displacement. For part B, they give us that 2 meters, which is our final, minus 6 meters, which is our initial, gives us negative 4 meters, which is our magnitude and direction of our displacement. And for part C, they give us that 7 meters minus negative 3 meters equals 10 meters, because our final minus our initial equals our displacement.